Alrighty, let's start with problem number 2. It's on page 3 of your thermodynamics lecture packet. So the equation that we need to use to solve our thermodynamics problems is Q equals ms delta T. M stands for mass or moles. How do you know? You're going to look at your specific heat capacity and base your M value off of your specific heat capacity units. A lot of times it's mass. So for a specific heat capacity, you might have units of kilojoules divided by grams times degrees Celsius or something like that. And at the end of the day, we're solving for our heat energy, our Q value. Remember, that has units of joules or kilojoules. So if we take a mass and it has units of grams, that will cancel out these grams here. And then we're going to multiply by delta T, which is going to get rid of degrees Celsius, and we'll just be left with kilojoules. The T, when you need to put in more specific information about T, it's really important that you get the order correct, because delta T stands for T final minus T initial. Negative values are just fine here. If you have a negative value, that's indicative of the fact that you have an exothermic reaction. What else do I want to say about this? Oh, the last thing is that I like to write it Q equals ms delta T. That's really the official way you're supposed to write it. But a lot of people will write it Q equals mc delta T. S is specific heat capacity. C is just heat capacity. There's subtle differences, but again, chemists don't really pay that much attention to the differences. So these two formulas are one and the same. Sometimes you say it this way, sometimes you say it that way. Let the units guide you when you're solving these problems. Alrighty, so let's go back to the problem. I'm going to erase all the details, but leave the formula up here for us to reference as we're solving the problem. So the problem asks us it gives us some information about a gold-colored rock. And we're asked to use the heat capacity of the gold-colored rock to see if it's gold or not. Let's organize our information first. So the student weighs the rock and she finds that it has a mass. So that's going to be letter M. The mass is 4.7 grams. She then finds that upon absorption of 57.2 joules of heat. Like, what can I do with that value? Well, that has the same units that we expect for Q. So I'm going to plug 57.2 in for joules. The temperature of the rock rises from 25 degrees Celsius. So our initial temperature was 25 degrees Celsius to 57 degrees Celsius. Find the specific heat capacity of the rock and then determine if we're dealing with a gold rock or not. I always think, why don't we just take the density of the rock? But whatever, we'll do it this way. Let's plug and chug it. So we have all this information here. Q is 57.2 joules. The mass of the rock is 4.7 grams. we are missing our specific heat, so I'll put that in red. And delta T is T final minus T initial. So I'm going to do 57 degrees Celsius minus 25 degrees Celsius. So this just becomes an algebra problem where we're looking to solve for specific heat, S. What should we do first? So maybe get rid of the parentheses. I'll do 57 minus 25. And that gives me 32. I'm going to take this step by step because with these recorded lectures too, you can't ask questions and I don't want to skip anything. People are like, oh, where did she get that number from? So bear with me as I drop my calculator and bear with me as I go through each step. So S, and then when I subtracted these two, I got positive 32 degrees Celsius. And then I can rearrange this so they're next to each other, and that'll be a good reminder that I can multiply the 4.7 grams times the 32 degrees Celsius. So multiplying these two, now I'm at 57.2 joules equals 150.4 grams times degrees Celsius. The S is still there. And then I want to bring this over. So I'm going to divide this side by 150.4 grams times degrees Celsius. And I'll do the same thing over here. And this cancels with this, and I'm just left with S. So 57.2 divided by 150.4. So S equals, how many sig figs? 2 sig figs? 0.38. Highly recommend you follow your units to this problem. It's going to be a lifesaver every time. So what's left? We got joules divided by grams times degrees Celsius. That's going to be our units. Alrighty, and so if you go back to the first page of the lecture handout, we have a bunch of specific heat capacities listed for different materials. Specific heat capacity is a constant. Like I was mentioning density before, she could have measured density to verify if it's gold or not. So those are some constants that won't change. If it's gold, it's going to have a known density. Same thing with the specific heat. But this specific heat resembles the specific heat that's closer to brass. So definitely not gold, probably something like brass, which is yellowish. But all right, cool. We'll move on to another problem here in just a second then. So normally number 3 would be the problem that I would ask you all to work on with one another in class and to give you some time to think about the approach. So if you haven't done number 3 on your own yet, pause the video and try to attempt it and then come back and look at the solution. So for number 3, again, I'm going to organize my information. My mass is 55.0 grams. And it says it's an aluminum block initially at 27.5 degrees Celsius. So my initial temperature is 27.5 degrees Celsius. And it absorbed 725 joules of heat. So Q equals 725 joules. What is the final temperature? Seems like we don't have enough information here. And actually we don't, right? Because if we look at Q equals MS delta T, just thinking about what I have Q, so I'm good to go on that. We got a mass. And actually, maybe I should have wrote this as Q equals MS, and then break this down a little bit, right? T final minus T initial. So we got Q, we got M, and we got the initial temperature, but we need the specific heat. And we need the final temperature. So 2 unknowns. we do have this information. Let me grab it. It's on that front page of the lecture handout. Or no, I keep on saying the front page. It's on the second page here. So specific heat of aluminum is 0.900 joules divided by grams times degrees Celsius. So now we have enough information because we can use the specific heat that we just looked up and plug that in as well. All right, let's do it then. 725 joules, 55.0 grams. Writing all the units, don't leave out the units. 0.900 joules divided by grams times degrees Celsius. T final is unknown here, so I'll put it in blue. And then we do know our initial temperature, that's 27.5 degrees Celsius. All right, so the unknown is in the parentheses. We could take the approach of like distributing to get rid of the parentheses, but I think it'll be a lot easier if first we multiply these two values and bring this new term over. So we're going to have 725 joules, multiply these, and also when I multiply them, the grams goes away. So grams is going to cancel grams. So 55 times 0.9, and I get 49.5. And then we still have T final minus 27.5. And again, distribution is a pain, so let's just divide this over. So 49.5 joules divided by degrees Celsius. Joules will cancel joules. Whenever you're in the bottom of a double fraction, like there's a fraction part here and then there's another fraction part here, the units will get flipped up to the top. So I'm going to do 725 divided by 49.5. I get 14.64646 degrees Celsius equals T final minus 27.5. My goal is to get T final, so I can add 27.5 to each side of my equation. All right, so 42.1 degrees Celsius equals T final. Thermodynamics, I'm always paranoid that I messed up. So I want to go back and look at my problem and make sure everything makes sense. So we had this aluminum block and it was absorbing heat. So it was undergoing an endothermic process. It was absorbing the heat, so I would expect the temperature to go up. We started at 27.5 and we ended up at 42.1. So, I mean, it's not 100% guaranteed, but you always want to just go back and kind of think about, do the numbers make sense? Well, yeah, it makes sense that this block started at 27.5 and went up to 42.1.